time to talk about ATX power supplies. These here are very useful for anyone doing electronics because they can provide the standard 12 volt, which you can see here, 12 volt, 5 volt and 3.3 volt at ridiculously high currents of 20 amps, 30 amps and 28 for each respective rail, and they're very easy to get and very versatile. Now these have a few problems and limitations. I have made a video talking about a very big ZVS I have, and I've talked about how I used two of these in series and I had a bunch of problems with them, and I would make a video on the ATX power supply and how you could surpass the problems, what problems I had and how I fixed them. So let's begin. Now, very quick, we are just real quick gonna unscrew everything. If I can get a screwdriver. Now I'll just cut the clip, I will unscrew everything, get the board out, and I'll be back. So we've got everything unscrewed and the chassis out, and we can see a bunch of components here. Now let's quickly talk through what everything is. We have mains voltage coming in from here that ends up here. Here we have a full bridge rectifier and its capacitors. Now this is turned by a MOSFET into an 100 kHz PWM signal, which then goes through these transformers and gets turned to 12 volts, well, approximately 12 volts, 5 volt and 3.3 volt AC, which is then being rectified and outputted. Now, the operation is that simple, but there is also, of course, like supervision, there's feedback between everything, protection and circuits and everything, so it's a bit complicated, but that's the basis of it. So, let's talk about problems that you could have while working with these. First problem is if you want to put these in series. So the problem with putting these in series is that the output, the negative output here, this thing here, the ground, which everything that's black here is connected to ground, is referenced to ground, the mains ground, and that is a problem because if you know electronics, if you go and put anything here, it'll short it to ground, it'll trigger OCP, and if you have OCP disabled, which I'll show you how to do that, it will brick your supply, it'll break it, might even catch on fire, not good things, not things we want. So how do we fix this? Well, you could fix it by unscrewing this wire here that is connected here. Now this wire is responsible for bringing the mains earth and earthing the chassis. Now, as you can see, you can take the screw and this wire will just hang around. Cut it off and isolate it if you want to use this method. But I wouldn't recommend using this method, and I will explain why. This wire here is like the only way earth's ground goes into the power supply. So if you take this off, yes, you unground the board, which is good, it's what you want, but you also unground the chassis. And by ungrounding the chassis, if a wire touches it, say something from the board or an output wire touched it, it'll short to ground and it will trigger your breaker and it'll be fine. If you have it ungrounded, if you take this wire out and you touch it, it might shock you. Not good, we don't want this, so we need to find another way. But how does this board get connected to the earth if there's only this wire? So if we flip this around, the board is connected through screw connections. You can see a screw here, there's a screw here, and there's a screw there and a screw there. Now what I've done, which I can't really show you, but you can kind of figure it out. You can unscrew the screws on all four sides and put washers that avoid making contact of this board. The board below has some solder points that connect to the chassis. Now, if you can stop this from happening, you can put a washer in between and screw it down. You can take a multimeter. If I can just grab one here real quick, 1 second. 1 second here, just give me a second. If I take this multimeter here, and I set it off to continuity mode, you might be able to hear it going off now. There we go. You should put one lead here and then take your other lead to any ground connection. I'm holding a ground wire here and connect it. Now, if you've done the mode correctly, there should be nothing, no sound. If you haven't done it correctly, when you touch the ground wire, you'll hear this sound, which means that the ground wire is still connected to the chassis and is getting it's getting reference to ground, which is bad. That means you haven't done it correctly. Take little washers, take little washers or anything else. I'll show you what I used here. This is just a like made of some fabric, I don't know, and you put it under the screw, and then you put the screw over it. It's like a bit below. You might even be able to see the red. There's some red there. You might be able to see that. So just do that on every screw, and if you've done it correctly, you will have no continuity of the meter. So we talked about that main thing. You can now connect this in series. Do this to all your power supplies except one. You can do this to all, but I'd like to leave one grounded, so it has reference to ground. You don't need to do them all. Like only this one's ungrounded. The other one is fine. So now that we talked how this mod is done, let's talk about something a bit more complex, but also as important. Now let's talk about OCP, or better known like OCP means that the power supply will draw too much current and shut down. This will happen when there's a short, or you just pull more current than you are supposed to. Now, the way my problem with this, say if I pulled over 12 volts, if I pulled like 10 amps on a 20 amp rail, would shut down. I wouldn't know why. So this power supply monitors the 12 volt rail, and when it drops under a certain voltage, it kills the power supply. By kills, I mean it shuts it down. This is called under voltage protection, and it's controlled by this IC here. You can kinda see it. It's like a 14 pin IC. If you Google the part number, this is a 205. If you get lucky, you can get a data sheet, but some data sheets are like some are in-house ICs and you can't find a data sheet. I will leave a post in the description that will give you a forum post with most pin-to-pin matches ICs. It'll help you lots. So you need 4 pins. You need, when you read your data sheet, you will have to find four pins. You need 3.3 volt, 5 volt, 12 volt, and sometimes you'll have a pin called PP or PT. And once you find that pin, what pin it is, you have to go ahead and ground it. So I'm just gonna show you real quick what I've done here. I'll just unscrew the board. I'll like unscrew all the screws from the board and show you below the board what I've done. I will also show you the mod I've done to unground it. So I'll unscrew everything and I'll be back. We're back. I have unscrewed 4 screws of the board, and now we can lift it up and take a look. This will be a bit hard because this power supply is kind of a bit shitty. Now you can see the spacers that I have there that essentially stop the connection. You see how these little things raise up and they touch the solder points. These points here, as you can see, they're a bit silver. These get connected to the case. Putting this here and screwing it down will stop this from touching the case and essentially unground it. So let's talk a bit more about the IC. Now, this area here is where the IC is, all the pins. Now, when you identify which pins you want to ground, take a ground wire. This here is a ground wire like I've done here, and go ahead and solder it on to all of those pins. Only make sure to solder the pins you need to solder. Don't ground anything else. It could kill your power supply. And when you have soldered these pins, you will notice that the pins also are connected to somewhere else on the board through traces. You will take an X-Acto knife or a normal knife, whatever you want, and you'll scratch away at the traces. You probably can't really see it. You might be able to see some damage with the wire. That's me scratching all the traces. And if you scratch the traces, you will see that there will no longer be a connection to the pins to anything else but ground. And when that happens, you have essentially disabled under voltage, over voltage, and over current. Now, I would never use this power supply in a normal computer, but for a bench, this is perfect. This is just what you need. So, be careful when you mess around with these and doing all these mods. Now, what I'll do, I will show you how to put these spaces down. So, you pretty much lay this over here. You put it right over the hole, as you can see there. You do it all over the holes. And then, when you do that, you take the board and you just put it over. Just put it over. And then take your screwdriver and one of the screws that the board was in, the board used. You put the screw over the hole and screw it in. Now, I'm not gonna screw it in right now, just to show you how it is. I'll just screw everything in when I'm done with it. But that's essentially it. That's everything you really need to disable on this. Some different ICs will need different pins to be grounded, but essentially these 4 pins are a safe bet. Some will just need to be desolder the pin or just ground the PP or PT pin. But generally, if you don't know exactly what you need, ground those 4 pins and then test it by doing the same thing you did before. It shouldn't shut down the power supply. And this power supply basically is as modest as I have it, and you can run in series. You can pull up to 480 watt, like 240 watts, which is quite a low range, but this is quite a low end power supply. It's not that strong, and it can power my ZVS perfectly, and it'll power my 500 watt Tesla coil in the future. And I want to make a video about it, and you will see a video about it when it's done. Now this has been it. It won't affect it won't affect any of the other voltages. It'll still be 3.3, 12 volts, and 5 volts. Just disabling the monitoring. Be a bit careful when running logic like Arduino and ESP like that. It can be a bit fussy and a bit dangerous. But yeah, this has been everything I have to say on ATX power supplies. If you want me to mention anything else, put it down in the comments. I'll be glad to hear it, and I'll make more videos about it, or tell you in the comments if it's short. But I'd like to share what I've learned with this, because I've learned a lot trying to figure out how to solve my problems. So thank you for watching this video. I will leave any post in the description and links to the other video, the ZVS. Please consider subscribing and checking out the videos. And that's it. Goodbye.